This is another video for April, what day is this? 6th and 7th. We're solving logarithmic and exponential equations. Highly recommend watching the first two videos to make sure you understand how to solve those equations. And now we want to solve these equations. Excuse me. Based off of what we talked about in the second video, we said that it would be great if we could isolate the logarithms. If we can isolate the logarithms on one side of the equation, then we can change it to an exponential form and solve from there. Here, though, we have two logarithms and then one on this side. So what would be great is if we could change and make this one logarithm, then we would have our logarithm isolated and our value on the other side. And we can do this. We can use what we call the product property, using the properties of exponents, which hopefully you have out. What the product property says is that we can make this as one logarithm, log, and if we do that, then what needs to happen is we multiply what's inside of our functions. So x times x minus 9 equals 1. Maybe go ahead and distribute and say this is x squared minus 9x equals 1. Now, after using the product property, we have the log function of one quantity equals 1. Now we can change it to its exponential form and use that to help solve our equation. So let's see how that would work. If we look at this equation, we're trying to figure out what is the base in this equation. Well, hopefully we can recall if it's just log, our base would be 10. So because it's just log, we don't have a base. It's understood that our base is 10. Our exponent is always opposite of our log, so to the first power, and that's going to equal x squared minus 9x. 10 to the first power would just give us 10 equals x squared minus 9x. And then from here, I saw a lot of people do some funky things that I was not too sure of. But hopefully we can recognize we have x squared, we have an x term, and we just have a number. So it takes a quadratic form. So we can solve it by getting 0 on one side. We can factor this guy. Two numbers that multiply to give us negative 10, that add to give us negative 9. Those two numbers being negative 10 and positive 1. Set each piece equal to 0 and get that x equals 10 and x equals negative 1. This is the key piece, going from our logarithmic to the exponential. If we can do this and go in reverse in terms of like what we did at the exponential equations, then we'll be in a good place. But this is the key piece that we need to get really good at before the assessment. Now, here we do need to check our values, because on the previous video I said the domain for our logarithmic functions is 0 to infinity, which means inside our log functions we can only take positive values. 0 to infinity, only positive values. So let's look here. If we plug in 10 here, it'd be log of 10. Is that positive? Yeah, it's a positive value inside our log. That works. 10 minus 1, it would be log of 1. That works as well. So 10 is a solution. We plug those into our log functions here. They stay positive values. And so that is a solution. However, if we plug in negative 1, here it would be log of negative 1. That's obviously not positive inside our function. Here, negative 1 minus 9 would give us negative 10. So log of negative 10, well, that doesn't work. We can't take the log of a negative value. So that does not work. And so our only solution here would be 10. All right, let's go over this next one, and then I'll post solutions for the other two, give you a hint for the other two, and then go from there. Here, we already have our log isolated. We don't have anything else happening over here. Two ways you could do it. You could change this to the power, make this x minus 8 raised to the 1/2, or we can go ahead and solve it. I'm going to suggest going ahead and solve it. I would try, even just for extra practice, use the power property. See if you can do it that way as well. But if we want to go ahead and turn this to an exponential equation or exponential, its equivalent exponential piece, we can do that. Ln stands for log to the base e. So if we switch this to its exponential form, our base would be e. Our exponent is always opposite of our log, so it'd be e to the 5th, and then this is going to equal square root of x minus 8. Now, a lot of people, some students got stuck here and said, well, e to the 5th. Yeah, we were going to leave that, just like we left square root of 7. Excuse me. Square root of 7 is an irrational number, so we just left it. Same thing here. We're going to leave this as e to the 5th. But we can keep solving for x. I mean, similar inverse operations that we always do. Here, remove the square root by squaring it. On the left-hand side, we have a power raised to a power. If we have a power raised to a power, we multiply the exponents. So this would be e to the 10th equals x minus 8. Again, irrational. So what we can do is add 8 to each side. And this would be our solution. Now we can say this with confidence because e to the 10th, e is a positive value, so if I raise it to any power, it's going to be positive. Positive value plus a positive value, that works. This is a solution. Is a solution. All right. All right, I'm going to give you a hint on these two. We could change this equation into this one, something similar, really quickly. All we would need to do here is if we added log to the base 2 of x minus 1 to both sides, that would get rid of it here, and this equation would become this. We can use the product property now, have the log of one value or one quantity, change it to the exponential, and go from there. You can do a similar thing here. I'm going to let you try that here on your own. If you try these two equations and solve, you end up with these solutions. So try that on your own. If you end up with a roadblock or have questions, please ask me in review, outside of class, through Mind Up, all those things. Hopefully this was helpful. And again, if you have questions, please let me know.